Alright, in this video, I'm gonna talk about the stability of structures. So this is probably the first topic when we study statics. So in many videos or lectures, you may learn how to apply the criteria to examine the structure is stable or not. So the criteria may go for like this. So we'll probably I've made sure the structure. So this is the planar structures. We have to have three reaction force, and these three reaction force cannot be parallel, and they cannot go to one point. So there's a long concurrent. So we know how to apply it, how to use it, but in some lectures they didn't explain it, so we don't know why this criteria works, why this criteria can determine the structure is stable or not. So here I'm gonna explain to you. So basically, this criteria works. That's because the structure, after structure satisfy this criteria, and that means the structure can satisfy the three equation of equilibrium. So as we know, the structure is stable. That does mean the structure is in equilibrium. So if a structure is in equilibrium, that means the structure satisfies three equations of equilibrium. So let's look now. Let's see how to apply this new method to check structure is stable or not. So first of all, look at the first structure. We know we have three reaction force, two on the support A, one on the roller support B. So this is the three reaction force. The three reaction force are not parallel and they are not concurrent. So these are stable structures. So this is based on the criteria shown here. So we can detect the structure just by observation. But if we're using a kind of the engineering way, we can decide the structure is stable or not as well. So for example, if we apply external loading, apply external loading on these structures, we can very easily to write down the three equation of equilibrium, and we can look at these three equations of equilibrium. Based on this case, we know all these equations of equilibrium are satisfied in this case. So that is mean the structure is stable. So look at the second examples. We know here the three reaction force go to one point. So these reaction force are concurrent reaction force. So based on this criteria, we know the structure is unstable, but we have to know why. So here is the reason. So we know the structure is unstable. So why? So because this structure cannot satisfy the equation of equilibrium. So for example, if we have external loading, over here, if we see, we can write down, can satisfy equation of equilibrium in x direction, equation of equilibrium in y direction. But if we write down moment equation of equilibrium at support B, we find the external loading P have some bending moment. We say the lever arm is like this, and all these three reaction force, because they go through support B, so they have zero bending moment. So these bending moments cannot equal to zero. That is mean this moment equation of equilibrium cannot be satisfied. So this structure is unstable. So this is the reason why this structure is not stable, because the moment equation of equilibrium cannot be satisfied. So similarly, let's look at the last examples. We know these all three reaction forces are parallel. So when we apply this case, we have to make sure all reaction force is parallel. So if only two of reaction force parallel, So that is not the parallel case. So we have to make sure all three reaction forces parallel. Then this structure is unstable. So why? Why? Similarly, so this structure cannot satisfy three equations of equilibrium. So if we apply external loading here, showing here, we can probably satisfy the equation of equilibrium in y direction. We can probably satisfy the moment equation of equilibrium. So for example, moment equation of equilibrium at support A, we can get some force values to satisfy this equation, but we cannot satisfy equation of equilibrium in x direction. For example, look at here. So this external loading have two components, Fx and Fy. So Fx is only one force in x direction. If Fx not equal to 0, so this equation cannot be satisfied. So that's why this structure is not stable.